right, section 2.6 is derivatives of trig functions. This section is not a lot of new information. It's just a tiny bit of new information, some new rules, and then we're going to see how that applies with the other rules that we've already learned. Product rule, chain rule, quotient rule, all that good stuff. Okay? So to get started with, you're going to write down the 6 trigonometric functions. All right? So first one, sine of x prime. The derivative of sine is cosine. The derivative of cosine is negative sine of x. Let me be real clear. The x's have to be there, of course, otherwise it doesn't have any meaning. The derivative of tangent is secant squared of x. The derivative of cotangent is negative cosecant squared of x. I kind of put them in pairs on purpose. If you remember them in pairs, it's a lot easier to sort of keep them, in your mind straight, I think. And then the last two, the derivative of secant is secant x tangent x. And the derivative of cosecant is negative cosecant x cotangent x. And what I'd like for you to take a look at on this particular slide is that these three here are the ones that have negatives in them, right? They're the only three that have negatives in them, and they're all co-functions: cosine, cotangent, and cosecant. So if you can remember that piece, that'll also help you keep your signs straight. Okay. So we're going to use these derivative rules as we work through some problems. The first problem that we're going to look at is 4 sine of 3x. Now, there is a chain rule in this problem because there is an understood set of parentheses that's not drawn in. Does anybody know where those parentheses actually are? Around the 3x part of the sine 3x, exactly. So they're right here. It helps me, anyway, to actually put those parentheses in to remind myself. So if it helps you, that might be something for you to consider. So there is a chain rule thing going on here. So as I take my derivative, the 4 is simply a constant multiplier. It goes in front. What's the derivative of sine? Cosine. The chain rule says I rewrite the inside exactly like it was before. No changes. Okay, so 3x. And then I need to multiply by the derivative of what's inside, which is 3. Very good. And then I've got this minus x here part on the ends. What's the derivative of that part? Yeah, so I've got minus 1. There's only a tiny little bit. If we were working on the quiz on Tuesday next week, you'd stop here. You wouldn't do anything else. But there is a tiny little bit for now that we can simplify because we can combine that 4 and that 3, and we can multiply them. So we actually get 12 cosine of 3x, the parentheses or not, either way, and then minus 1. Yes, Luke?
If we solve further on the quiz, just kind of by accident, will we use one?
If you make a mistake in solving, you will. Yes. So if you did this on the quiz, for instance, and somehow in your mind you decided to add 4 plus 3, for instance, stranger things have happened, and you put a 7 on there, then you would lose points. You would not get the problem correct. So if you simplify something incorrectly on the quiz, you will lose points because you're not supposed to be simplifying at all. But if you do something incorrect, I will take off for it.
So if you just simplify and get it right?
If you simplify and get it right, that's fine.
Is that top line what we would need on the quiz?
Yeah, the top line is what you would leave on the quiz. It's just fine. If you write it the second way, it's fine too. It's just that if you make a mistake in doing so, and this one's, you're probably not going to on this particular one, but there are some that you might, right? Then that's where things are going to be unfortunate.
So does that mean like on the quiz, can we have like halves, like exponents and like
Everything.
negative exponents?
Mm-hmm. Everything as you do the original problem, you can do that on the quiz. And I know that you guys have some questions about it. If you download the images that I was telling you about that are on Moodle Rooms, you'll see exactly how much you can leave unsimplified. it's all of it. You can leave everything unsimplified when you do it on the quiz. Yeah. Okay, let's try another problem. We've got g of x equals x squared over cosecant to the 4th of 2x. So what kind of rule do you see going on here? Quotient rule. Yeah, and if you really wanted to pull that cosecant to the 4th up and make it a negative 4th power and do a product rule, that'd be fine too. But this is a quotient rule the way it's written. So let's just do it from the quotient rule because we haven't done one of those yet today. All right, so we're going to do g prime of x. What does the quotient rule say that I do first?
Regular denominator.
Rewrite or regular denominator. You got it. So cosecant to the fourth of 2x. Then what do I do?
Times the derivative of the numerator.
Okay, and what's the derivative of the numerator?
2x.
2x. Nice.
Subtract the opposite.
And subtract the opposite. All right, so that means I need to rewrite the numerator now, right? So like x squared. And then I need the derivative of the denominator. Well, that's kind of where this whole section's coming from, right? So what in the world is going on? I mean, I don't have cosecant to the fourth. I mean, what am I going to do?
Split it up.
Yeah, so cosecant right here, let me just rewrite to make us ourselves aware of it. That 4 right there is actually like a 4 out here, right? That's what that means. So this is a chain rule, exactly. And it's actually a double chain rule. Isn't it? Do you guys see that? You've got the chain with the power 4 on the outside, but you've also got a chain with the cosecant on the outside of a 2x. So as we're working through this, we're going to get 3 parts of the answer. There's going to be an answer that's going to have 3 parts on this particular portion of it. So the first thing I do is the power of the 4 on the outside. So what do? 4 comes down, and then I've got cosecant of 2x to what power? 3. So the cosecant 2x part doesn't change, right? I'm definitely going to run out of space. Let me move this a little bit over. I'm not doing a good job of selecting it all. Just a sec. There we go. All right. So I did the derivative of the power of the 4 part, right? The power 4. So now what do I need the derivative of?
The inside.
The inside. I need the derivative of the cosecant, right? So what is the derivative of cosecant?
Negative cosecant.
Right. Negative cosecant of x, but our x is 2x. So negative cosecant 2x, cotangent 2x. Okay, because our inside, our angle is 2x. It stays the same. And then what? Times 2. Okay, you may not like it, but is everybody good with where everything came from? Yeah? Okay. What's the denominator going to be? Cosecant to the fourth of 2x squared, which feels a little bit awkward, but I could also rewrite it as cosecant to what power? The 8. Believe it or not, there's quite a bit that can be cleaned up. I know you had no idea, right? You thought it was going to be all messy. If you were in the quiz, though, you'd stop right here, agreed?
Yep.
And that would be friendly. The answer doesn't look friendly, but it would be friendly that you didn't have to keep solving to find the answer. So we're going to simplify this a little bit. The parts where I have a coefficient like the 2x or a multiplier, I'm going to put it in front just so that it doesn't end up in my mind sort of thinking I can somehow multiply it by the angle, because I can't. It's multiplied by the trig function cosine of the angle. So I'm going to put the 2x in front of the cosecant to the fourth of 2x. And then over here, I've got negative 4x squared, right, with those 2 pieces. I actually haven't have a positive because there's a negative here and a negative here, so I'll change this to a positive. How many cosecants do I have? I have 4. This is cosecant cubed, and then I have another cosecant here, so there are 4 of them. So this is actually another cosecant to the fourth of 2x. And then I have cotangent of 2x. And this is all over cosecant to the eighth of 2x. What's that?
I was going to ask about changing the sign, but you did.
I did, yes. Oh, I did leave off the 2. It's off my screen of what I'm seeing. Over here, this 2 right here. Sorry about that. So instead of this 4 here, I guess I'll have 8. right? So I had a 2 at the end I was leaving off. Do you see they have cosecant in every term? Did you have a question to answer?
So like, I guess you kind of factored out that negative or whatever to make that a positive.
I just collected them. It's all multiplication. So anytime you multiply 2 negatives, you get a positive.
Right.
Mhm. Yeah.
Okay.
So I
just
simplified
didn't
that.
think you could since I had parentheses.
You couldn't if the parentheses included like addition or subtraction in the parentheses. You'd have to do some sort of distribution, but I don't have any addition or subtraction inside any of those parentheses. It's all multiplication. Yeah. Okay, do you guys see the cosecant to the fourth in every, or cosecant rather, in every term? So we could factor that out in front, right? Or you could simply recognize, hey, these are going to reduce. And so there's 4 of them here, and there's 4 of them here, and there's 8 of them down here. So I'm going to reduce them, leaving how many of them where? 4 of them on the bottom, right? So in front now, I've got 2x plus 8x squared cotangent of 2x over cosecant to the fourth of 2x. And then we're done. Any questions on that one? Are you all good with why and how I simplified the cotangent part of, or the cosecant part of it? Okay. Let's try another one. We're supposed to find the derivative of 4 sine squared of 3t plus 4 cosine squared of 3t. Now, I want to pause with you for a moment and think about this. We could use chain rules, agreed? I've got squareds on these things, and I can do the same thing I did with the cosecant with the power 4 a moment ago. But if you're being aware of what's going on, the problem's a lot easier than that. So take a look here. Both of these have a coefficient of 4, correct? So before I take any derivatives, I'm going to pull that 4 out and see that I have sine squared of 3t plus the cosine squared of 3t. Who's had trig recently? What's sine squared plus cosine squared? 1. So this is just 4 times 1, or 4. So my function, h of t, is equivalent to the value 4. What's the derivative of 4? 0.
So it doesn't matter what's inside of sine and cosine.
As long as they match.
So because 3t and 3t are both the same?
Since they match, yeah. If one of them had said 3t and the other had said 4t or something like that, we couldn't do this. But because they match, it works. And if you do this with the chain rule and then you simplify it, you're going to get the same answer. It's just going to be a whole lot more work, right? So you're working with trig functions. Now would be a good time to sort of remember some of those details, some of those rules. And since you're going to be going out there to print it off anyway, you can print off a list of the different trig identities that might be helpful for you. They're on our Moodle Room site. Okay. There's also a flap in your book. You're exactly right. All right, let's take a look at another one. What's the difference in this particular question from the one we were doing before? Yeah, okay, so first it talks about a tangent line, right? Specifically, we're going to find a tangent line. And then in order to do that, they have to tell us what particular point we're looking at, a equals pi halves. So we've got 2 pieces of this going on. Everybody good so far? Okay, do you guys have your calculators with you today? You go ahead and grab those out, because after we do this one, I'm going to remind you or show you. I don't think I've shown you yet how you can use your calculator to be helpful in verifying things, and so I'm going to show you that today. So let's start with the equation of the tangent line, just like we've been working with in other sections. So this is y minus y1 equals m times x minus x1, right? And this value a equals pi halves, what is that information in this particular equation? That's the x1 value. So we've got pi halves right there. So the easy thing, the first one that's the easy one to find is what? y1. How do I find y1?
Plug into the original, or plug your x
Exactly. So my original function is f of x. So I'm going to do f of pi halves is pi over 2 squared times the cosine of pi over 2. So let's start with cosine of pi halves. So this would be one of those times when you might want to start thinking about remembering your unit circle. And your calculator can help you sometimes, but it doesn't give you exact answers all the time. It should still be in radian mode. I think we've already done that, so making sure on that. But what is the cosine of pi halves? What is it? Somebody said it. It's 0, right? The cosine of pi halves is 0. So what happens to this whole function right here? Put it there.
0.
Yeah, it's 0. So my y1 value is 0. That's friendly. The only thing left to find is m. And how do I find m? Derivative. Yes, that's right. I'm seeing some people mouthing it. So let's find the derivative. Now, this particular function is going to use what rule? Product rule. But it's actually pretty clean in the sense that neither of them are complicated functions, right? X squared is pretty simple, cosine's pretty simple, so that's kind of nice. So product rule, what am I going to do first? Rewrite the first one. What's next? Take the derivative of cosine. So what's the derivative of cosine? Negative sine of x. Product rule uses addition. After my addition, what am I going to have? 2x, right? The derivative of x squared, which is 2x, and then what? Cosine of x. So I'm rewriting the cosine of x piece, and I'm taking the derivative of the x squared piece in that step. I'm going to pull that negative to the front, but that's really the only thing that I'm going to simplify here. Even if I could simplify more, I wouldn't, because why? Yeah, I really only need to find out what in the world the value is at a particular point. In this particular case, it's the point pi halves. So I need to find out what is f prime of pi halves. So we've got negative pi halves squared, sine of pi halves, plus 2 pi halves, cosine of pi halves.
So that negative though does not go with the x.
No, it doesn't. Only the x is squared. The negative is multiplied by the quantity x squared. You can remember rules or orders of operations where exponents come before multiplication, and that's a multiplication fact in front. All right. What is the sine of pi halves?
1. No, wait. 2.
You were 1. You were right the first time. It's 1. The pi halves would then be pi squared over 4, right? And this is 2 times pi halves. This is actually pi. What's the cosine of pi halves? That one's 0. We did that one just a minute ago. So this piece goes away. So the only thing I actually end up with is negative pi squared over 4. So my slope is negative pi halves divided by 4. Now we're going to keep our equation as exact as we can because we have the ability to do so. So this is actually going to be y minus 0, so this is y equals negative pi squared over 4 times x minus pi over 2, which we can simplify. So this is y equals pi squared over 4x, and then I have plus pi cubed over 8. Now, I'm going to show you something in your calculator. It's not going to put things in terms of pi, so let me just tell you that right quick. Okay, so my answer that I'm going to get from the calculator is going to be an approximation. Sometimes an approximation's fine, depends on the context of the problem. And sometimes it'll actually give you a whole answer because, like the actual answer, because it's not going to need to approximate. It's going to be a whole number or maybe a fraction or something like that. But I want to talk to you about how to actually put this in your calculator in a way that would be helpful, at least to verify that you did it right. Make sense? So what your calculator is going to be able to do here as we look at this is it's going to get, I'm going to show you how it can give you an approximation for the derivative at a specific point. So that's what we're going to let our calculator help us with. So what I want you to do is I want you to put the original equation, the f of x equals x squared cosine x, into y1. So in your calculator, you're going to put in y1 equals x squared cosine of x. Okay. Once everybody's done with that, kind of look up at me and let me know so that I can tell you what to do next. Most of you are getting close. After you've put that in, go out into the regular screen, not the graphing screen, just the regular calculation screen. I want you to press the math button. And the option I want you to pick is option number 8. Now, depending on your calculator will depend on what shows up visually. If you have an older operating system on your calculator, it will say inderiv. Who has a screen now that says inderiv? Raise your hand. Okay, a few of you do. If you have the newer operating system, it's going to actually look like a dy dx, I think. Is that what it says?
D over dx.
D over dx. Okay,
Yeah.
very good. All right, so let me talk to the people who says inderiv first. Okay, so if yours says inderiv, I'm talking to you. The notation your calculator wants you to use after you do inderiv, which is now what's on your screen, it puts it in like this, is you first have to tell it that your equation is y1. So where do you get that? Well, you get that underneath the vars key for variables. So hit vars. It's underneath the keypad that looks like the arrows. Do you see the VARS button under the arrows? Go over to y vars. It's a y variable. We're working with functions, so select function. And then you get a list of y1, y2, y3. You select y1. Okay. There's a comma key on your calculator, so you're going to put a comma next. And then you're going to put an x. This x is telling it my variable's x. So basically what you're telling your calculator is, I want to find a derivative of the equation y1 where the variable is x. So far, so good? But it does not do it in general. It has to do it at a specific point, so you need to tell it what point you're doing it at. And for this problem, we're doing this at pi halves. So you tell it pi halves. If you press enter, it's going to do the calculation. And it's going to give you this value, but it's going to give you the value of negative pi squared over 4 as a decimal approximation. Okay, so what it gives you, you can compare that by typing in negative pi squared over 4 and see that it's actually the same decimal expansion. All right, so let me look at the other version of the calculator because I know how to do it, but I don't have this one. So, all right, so on this one, if you've got that other math texty type thing, it says d and it has a d in the denominator, right? So you need to go down to the denominator and you need to put the variable x. So you're telling it I want the derivative with respect to x, d dx. The part that's in parentheses needs to say y1. So you get the y1 the same way. You're going to hit vars. You're going to go over to y vars. You're going to select function, so press enter. And you're going to select y1 because that's where we stored our equation. And then it says x, and it has a little, like it has a line that says x equals over here down in the corner. You guys see that? That's where you're going to put your pi halves. So you're putting all the same information in that the other group did. Okay, it's just going to be in a different place. So after you enter pi halves, hit enter. It's going to give you a decimal approximation. You're expecting that it's supposed to be negative pi squared over 4, so on the next line, just type in negative pi squared over 4. And compare them. It should look like the same decimal approximation. Now, did it work out okay? Yeah? Everybody's works?
Yep.
Excellent. So on this problem, it doesn't help you to actually find the answer, and in most cases that's probably fine because you're going to have to show the work that you found the answer anyway. But at the very least, it actually can verify for you that you found the right answer, and that's helpful. Okay? Cool feature, right? All right. There's one other way you can do it. All right, so you've got your y equals. Go back into your graph, and let's actually graph the thing. And the graph has to include this point at pi halves. So let's hit our window. And actually, even better than hit window, hit zoom 7, which is the zoom trig window, because that'll put it in the standard trig window. So if you do zoom 7, I think it's 7. Is that right? Is 7 trig? 6 is standard.
I've got to wait for it to
Okay.
so I can reset the window.
So you hit zoom, yeah, it's 7 trig, okay, good. Hit zoom 7, and then, okay, I haven't done this one. There's a button that says calc. Okay, you see the trace button? See the button that actually says trace? If you hit your second key and you hit the trace button, it gives you the calculate menu. On the calculate menu, number 6 says dy dx. You guys see that? 6. So select number 6. And then you can actually type in pi. I know it doesn't look like it's ready to type anything, but you can actually type in pi divided by 2 and press enter, and it will calculate it on this screen as well. You don't actually, that's actually a really nice feature. You don't actually have to enter in all the details of the Math 8 and all of that. The caveat is that you actually have to be able to see the pi halves on your screen. So you can't like tell it, oh, I want to do it at, like 50 pi. Well, 50 pi is not in this particular window. It won't work. Yes, Luke?
Also, if you kind of want to check like your final equation,
Yes.
you can plug that in, and then you know that it has to be tangent to your main line at the point pi over 2. So you type in pi over 2, and if both the values are the same, there's a good chance that you have the right line.
Yes, that's exactly correct. And we've done most of what you described before, not the very end piece of it, but most of what we've described before too. So if you want to check your final solution, you can actually put this into y2, right, and graph it. And you should be finding that you have a tangent line visually that's tangent at the pi halves value. So if you put this into y2, you should get, and your screen, if it's set up in Zoom Trig, should set things up in, I think the intervals that it puts it in are pi fourths or pi halves. So you should be able to verify visually that it seems like a reasonable solution to your problem. And yeah, if you go into your table and you put in pi over 2, they should have the same y value at the very least, for sure. Okay, any questions on this one? On the calculator stuff? Okay, one more problem that we're going to look at. This one says differentiate the following. Now, this is an interesting problem because it doesn't ask you to find f prime. It asks you to find the derivative, but it asks you to find which derivative? The 75th derivative, and we're also going to do the 150th derivative. How fun is that? Well, it's not as crazy as it sounds. In general, this is not a very productive idea, but when you're working with trig functions, it's pretty easy to do it. So let me show you what happens, and we're going to show you what happens based on finding several derivatives that are not the 75th or the 150th, obviously. But we're just going to try and notice a pattern. That's our goal. So we found, or we were given rather, f prime, or f of x, sorry, as sine x. Let's find f prime. So if I find f prime, what's the derivative of sine? Cosine. So the derivative of sine 2x is cosine of 2x. What's the derivative of the 2x? 2. And for the sake of argument, for the sake of clarity, I'm going to put the 2 in front. We talked about that in the last couple slides ago. Putting the 2 in front. I don't want to think that I'm multiplying the 2 by the 2x. So I'm going to put my 2 in front. We're going to do it again. We're going to find f double prime, the second derivative. So the 2 is going to be part of my answer. What's the derivative of cosine? Negative sine. So I'm going to put the negative in front of the 2, and I'm going to put the sine of 2x here. But I still have 2x as the inside function. So what is the derivative of the 2x? 2. Another 2. So instead of the 2, I could actually have the number 4 written, or perhaps it would even be more helpful to write this as 2 times 2. Just so that you can see that there's double the 2's there.
Negative 2 times.
Yeah, negative 2 and then another 2, exactly. Negative 2 times 2 sine 2x. Let's do this a third time. I'm going to have the negative 2 times 2. None of that changes. What's the derivative of sine? Cosine of 2x. And then I've got another derivative of the 2x, so I get another 2. So I have 3 2's. I promise we're getting close. Let's do the fourth derivative. So the negative 2, 2, 2, all that stays. I've got the derivative of cosine. What's the derivative of cosine? Negative sine. So actually I'm going to change my sign, right? I've already got a negative. I'm getting another negative when I do the derivative of cosine, so this one will be positive. And I also get another 2, right? So think with me. If I want to do the 75th derivative, let's just look at how many 2's I should have. How many 2's am I going to have if I take a derivative 75 times? 75 of them. And you can see it really easily, right? Because as I wrote down a few of these, we quickly realized, hey, look, third derivative, 3 2s, fourth derivative, 4 2s. So when I do my 75th derivative, I'm going to get 2 to the 75th power, exactly. Now that doesn't finish the problem, but that's the first piece I wanted to recognize. That's maybe the simplest piece to do. I want to do one more derivative, the 5th derivative here. I know I'm going to get 5 2s, right? The derivative of sine is cosine. And what I want you to see or to recognize is the pattern is starting all over again. Do you say this? So I'm sorry, that was supposed to be a highlighter. This was my original function. It had sine 2x in it.
With this,
When I got to my 4th derivative, I got another sine 2x. Do you see that?
would the last one though have a negative 2?
Would it have a negative in it?
5, like with all the 2's?
Well, the derivative of sine is positive cosine, so no, it won't.
Okay.
The negative would come into play on the next step, though. If I took the derivative of cosine, I'd get a negative sign. Now, take a look at this, though. Here's the first derivative, yeah? That color did not work for me. Let me try another one. It has a cosine of 2x in it, and the 5th derivative also had a cosine of 2x in it. The 6th derivative, what's it going to have in there?
Negative sign.
It's going to have a sine, and then it's going to have... So first of all, sine and cosine are just going back and forth, right? Okay, so when we were looking at the odd derivatives, right, the first one and the third one, I'm getting cosine of 2x, agreed? For odd derivatives. And if I'm looking at the even ones, I'm getting sines of 2x's, agreed? So if I'm looking at the 75th derivative, am I going to have a cosine or am I going to have a sine?
Cosine.
I'm going to have a cosine. Now the last thing I have to decide is I have to decide if I'm going to be getting a negative or a positive.
I think it would be positive,
How do you decide?
because it's a multiple of 5.
Multiple of 5 isn't going to be helpful, but you're on the right track. You're so close. Let me erase this one to show you something.
It's also a multiple of 3.
It's going to be...
Multiple of 3 is not helpful
it's
either.
gonna be negative because it's an odd.
How do you decide? Well, not all the odd ones are negative.
Well, it repeats every 4, so the nearest to like 72 divided by 4 is 18, and then you have 3 extra, so that brings you down to a negative numbers.
Okay. So, Will, you're right on the idea of looking at multiples, but the multiples we don't want to look at are 5s and 3s, it's 4s. This repeats every 4 times, right? Every 4 times the pattern repeats, agreed? I get the exact same thing I had 4 times before, in terms of the positive or the negative, in terms of the sines or the cosines I do. So what I'd actually like to look at is I'd like to look at what happens when I would look at dividing 75 by 4. So 75 divided by 4 is going to give me something. I don't even care what the something is. It's the remainder that I care about. What do I get when I divide 75 by 4? What is the whole number? You grab your calculator. What do I get? 18? What is 18 times 4? Is your 72? Is that what you were telling me a minute ago? So there's a 3. The remainder of 3, which is a 0.75 when you look at the decimal for it, the 0.75, tells me that you go down 1, 2, 3, and you're right here. Because if I do this 4 times, I get the 4th derivative. If I do it 8 times, I get the 8th derivative. If I did it 12 times, it'd be down to the 12th derivative. So I'm going up by multiples of 4. So if I did it 18 times, I would actually be down here at the 75th, or not 75th, 72nd time through. I would be back down at the bottom again. And so the 73rd one would be the same as the first derivative, 74th one would be the same as the second derivative, and the 75th one would be the same as the third derivative. So I do get a negative. That's what the pattern is doing. So this one is actually going to be a negative value here. So we worked really hard to establish that pattern. Let's see if we can apply it with the second part of this question, part B, which is f prime of f of 1/50th. 150. The 150th derivative. We'll just say that. All right, to start with, what is the 2 to what power? What do I get? 2 to the 150, very good. I'm looking at an even number, so am I going to get a sine or a cosine? I'm going to get a sine. Make sure you're saying sine of 2x. And then, where am I? What's going to happen if I try to divide 150 by 4? I get a 0.5, right? Which is the same as a remainder of 2, which means I'm right here at the same thing as a second derivative. I would having a remainder of 2. So do I have a positive or a negative? I have a negative. That's B. Sorry, this one's A. Kind of crazy, right? That only works with trig functions. Polynomials don't do that, right? I mean, so this is something that's unique to trig functions.